Hey folks, we have some in-house Spark experts and Lakehouse experts. This is an AMA session. Feel free to ask whatever questions you have. All right, go ahead folks, take it over.
This is very interactive. So what we're going to do is we do a quick round of intro, and then I'm going to start maybe poking some questions nasty, and then I will give this over to you to basically repeat this on your end. So hey, Hyukjin, why don't you say who you are and what you're working on?
Yeah, hello everyone. I'm Hyukjin Kwon. I developed the Spark core stuff, and then I'm the open source Apache Spark, and then I'm now doing the Python PySpark tech lead, and then now I'm #1 contributor in Apache Spark repo.
Woohoo!
Okay. Hello everyone. I'm Wenchen fan, and I work on the Spark team in Databricks. So I have been working on Apache Spark for more than 8 years. So within the Spark is still not Apache. So I work on the Spark at the beginning, and then I moved to Spark SQL, and then now I'm the tech lead in the SQL team in the Databricks Spark org.
And then my name is Mary Grace Mesta. I'm a senior data science consultant from Databricks, so I work in our professional services practice. So I'm more on the Lakehouse, on the application, how this stuff works in real life. So yeah, I've been working in Spark for 5 years now. So yeah, happy to answer any of your questions.
All right, I'm Martin. I'm a tech lead in Databricks. I work mostly on things like Spark Connect, governance, and security. Yeah, so I've been working on Spark only for 2 years now, and that's but I come from actual databases. No, okay. So all right, so how do we get started? All right, so I think everybody talks about LLM these days. So Mary, I have no idea about machine learning. This is all 7 books to me. Why don't you give me this kind of this answer of why do I need to care actually?
Care about LLMs and Lakehouse
Yeah.
for your LM? Yeah. Great question. So the approach that we always take to machine learning is a data-centric one, right? Our models are only as good as the data that we have. And so making sure that our data lives in a lakehouse that's well-governed, that's accessible to people, not only opens up these models for these massive applications, but also as we start to do things like drift and understand the evaluation of these LLMs much, much more, we can use all of that response, that evaluation data to better inform the entire end-to-end process. So having this centrally located in a lakehouse is going to enable us to do that and make sure that these LLMs not only perform well, but are things ethical and are actually giving reasonable and appropriate responses to whatever our users are asking of it.
Awesome, thank you. All right, so I will give it to the audience. Anybody having a question that they want to always ask somebody that's day-to-day committing to Spark or working with Spark?
We got a packed room here, so.
Absolutely.
Not everyone at once. No, nothing. Anyone's? Oh, curious.
All right,
Okay.
awesome.
So, oh, that's really loud. Sorry. So we have a bunch of relational database engineers, data engineers that are migrating over to Databricks. And one of the big questions we have is, with the medallion architecture set up, what's the most appropriate data model for your silver layer? Or do you even apply a data model? Would you go with a highly normalized model, or would you denormalize and do something that's more wider table?
All right. Who wants to take this one?
Yeah.
Mary, maybe again?
Yeah,
Sorry.
I think in terms of what we see in practice, the data model for that silver layer depends on how it's going to be consumed, right? Are you going to have data scientists pulling directly from it? Or is this or are you going to reserve that just to be pulled from your gold layer? I think understanding that access pattern of the application of those silver features kind of better informs what sort of logic layer is applied there.
Yeah, that's a good point. So right now we don't have anyone working on the data science side of it, but I think that's a future goal.
Yeah.
So having, say, keeping a time trend, for example, instead of having just the latest data, would be something we'd be interested in. And then, so that would obviously increase the size of your tables over time.
Yeah,
right?
but so the size is a concern?
No.
I was gonna say that if we're in a object storage, size shouldn't necessarily be the concern. So you're asking what is the logical jump from bronze to silver? Like what happens there?
Right, because right now what we're struggling with is the way that it's set up currently is we have a pain point in the going from bronze to silver and to gold because of and seeing slower performance because of how everything's joining up together. So we're trying to figure out how to best optimize that, and I think that one of the core problems is the data model we're using, where we're applying a lot of joins to silver when we should probably be reserving that to gold, for example.
Yeah, definitely. I think in terms of what we typically see is reserving some of those really big joins for that gold layer. So splitting up some of them. So you, can you tier, like is there a hierarchy to those joins at all?
Not currently, but
Okay.
you probably could.
Yeah. So I think like if you are able to sort of tier or provide, like I said, some sort of like hierarchy to those joins and split them across silver and gold, it will be able to at least split up some of that computation so it's not as slow as it is before. But then there's also a lot of knobs you can turn, and I'll lean on the Spark people, to speed up those joins from a Spark performance perspective.
Well, that's kind of my biggest question is, should you even do joins, or should you just refine your bronze tables and keep the same number of delta tables as what's in your bronze layer?
So this is kind of debated. I personally think that you should do joins, and most of like our engineering community I think would kind of back me up on that one, because if you have, it just de-risks a lot of potential issues that can come out if you just have people querying directly from bronze. Bronze is meant to be a raw landing zone that not many people touch because it's not the most understandable data. I think it is much worth it to add those joins, because you can think about it as you move up from bronze, silver to gold, joins to joins to joins, you increase the fidelity of your data. And so if I know I'm pulling from gold table, I know I'm pulling from a really high fidelity data source. Silver might not be as reliable, but then if you're constantly pulling from bronze, that variability of like, I don't know what I'm gonna get, just continues, whether you're in prod or like dev data.
Okay, so maybe like a denormalized star schema type approach.
Yeah.
Okay,
Yeah.
perfect.
All right. Maybe I can use this as a question to the audience. Like, are you using more Python or more Scala? Like, what's the distribution here? Like, what kind of questions have you on either end? So we have a Python expert and we have a Scala expert. So like, you can ask all your nasty questions there. So what's like, maybe show of hands, like who uses more Python? Okay. And the poor Scala person, like who's that? All right. 2. Wow. Awesome. So maybe then, why do you use Scala, and like, what would you want better from Spark? And then maybe like Wenchen can help you with some answers on that. Oh, sorry, the mic is coming if you don't
Kind of putting you on the spot, but.
not at all. I don't put anybody on spot here. You don't have to leave. I'm really a nice person.
So I actually had a different question, but we've been using an older version of Spark. So like I was in a session about, deep dive into the new features of the 3.4. But since we're well older than that, just in general, I don't know, over the past year or two, like what's kind of like the biggest feature outside of just what's in 3.4 that I should watch out for?
Okay, so if you watch the talk, it just happened, I think, a few hours today. Yeah.
But I'm on a much, much older version.
Yes. So yeah, this is a well-known problem because Spark is very big, so it contains many dependencies. So when you upgrade to a new version, it may break your application in different ways, and also there may be behavior change or maybe bugs, right? So this problem I think will be solved by the Spark Connect project. So in the future, so we will separate the server and the client, so you can upgrade your server to a newer version with new features, but you can still remain your client at the older version. So I mean, this can keep your application safe when you upgrade the Spark versions. But for now, I think it's really a hard problem. Even our customers will have a painful time when they upgrade their version, because they may need to update their downstream libraries or whatever, some application code. So yeah, that's the future.
Thank you.
So what's the one thing, like what stops you from upgrading to newer versions of Spark? Or the 2 things, I don't know.
So yeah, we're actually not Databricks customers, but
It doesn't matter.
but yeah, we've got a plan on how to spin up our own instances that are compatible with like Spark 3.4. So just something I'll be looking at when I get back from the conference. Okay. But I mean, there's much more than just like the 3.4 deep, new features deep dive. Like since I'm on a much older version, I got plenty to explore.
Beyond 2 or still below 2?
2.
I mean, enjoy. I mean, there's an interesting question there, which is like there's all of these things where it's what makes the upgrade hard? Well, and like I think this for us as like part of the community, it's always very valuable to understand. It's like, what are the things, like where does the friction go? Like if you have feedback for us, it's like always looking for it.
Sure.
I mean, independent of Databricks. I mean, like again, like we're all open source committers as well, and like trying to basically like evolve the Spark project, and it's very much independent of Databricks as a company here.
Yeah.
All right. Any other questions? Maybe was this a question? I saw like there was a hand raising. Don't yawn. Like I will find you.
Yeah. What question do I have? Yeah, I actually I'm just thinking like for the reason we kind of use Scala is because so we want to kind of understand how code is being executed, and also especially when interact with, I guess, external data sources. Like for example, we're also using Snowflake and Kafka. Like all these different connectors are, the core functionality are written in Scala. And if there are scenarios we need to, I guess, look into the code, if we only familiar with Python, that would be kind of hard for us to figure out what's going on. I guess the general question I have is is there any plan for, I guess, Spark experts, you guys, to develop any data access control module within Spark? Because I think most of the use case, what we're facing is we just have we're running things on AWS, we're also using Databricks. We just attach, Amro's instance profile to the compute engine, and everyone running things on that cluster will have like exactly the same permission. I know there's a Unity catalog, but I just wonder if there's any plan in the open source project for this type of field. Yeah.
So to paraphrase the question as well, like is there any efforts on like building like an open source governance layer in Spark?
Yeah, I guess there isn't a plan for doing the government, but I think it makes more sense to have that as a like third-party project, right? For instance, forgot the
Ranger.
name. Yeah.
Ranger.
Yeah. Ranger, and then I think it makes sense to have it as a like third-party project for now. Yeah.
I think this is what we've seen as well. It's like many customers, like they're either using like Apache Ranger, or they're then using like the different commercial, like versions of it. I mean, there's Immuta, and then there's Privacera, and they all like have their different offerings that like integrate fairly well with Spark. I think this is one of these challenges where Spark as a project is like so big that it becomes very hard to define like a unified standard of like how you integrate, and because there's so many different ways of like interacting with the data, and this is where these kind of vendors have found like a good way to provide these kind of functionalities where you can say, okay, you have to level one layer up. Well, so Spark itself is this kind of like, hey, I'm reading files, and now you basically the next step is like, okay, tables, awesome. And then there's like, you want to have like attribute-based access control on the table. So there's a number of things that you want to do, but it's not really where Spark like has its own like things, like catalog is not part of Spark. So Hive Metastore is not part of a Spark project. So that's why it's like, it's a little bit unfortunate. I mean, again, like I can say there was only 2 years of Spark history. I can still like have weird feelings about like this thing not having a catalog, but I think this is one of those challenges where like you have a number of like systems that are tied together, but it comes with a lot of benefits as well that you can choose essentially what you want to run on.
I see. Yeah, thanks for that answer. Another quick question I have is, I guess, related to Python versus Scala. It seems to me like a lot of new features Databricks is building is now prioritizing Python and SQL, and even for, I guess, the new execution engine Photon is replacing Scala. It's not using Scala at all. So I'm just wondering. I mean, I'm just heard like it's C++. So does that mean for Databricks and Spark community, the prioritization or the common vision is it's going to be focusing more on Python and SQL rather than Scala?
Sorry, I have a bit of like hearing problems.
All
Can you just,
right. The question is if basically Scala is compared to Python and SQL a little bit behind. Like, where do new features come? Like, is this more on the Scala side, more on the Python side? Like, is there still is there parity? Is there desired parity? What's the priority for us as a company? What's the priority for the community?
Yes, so I believe we used to have some new features a bit late, especially in other languages like Python or R. But now, since we are prioritizing the Python, many people use Python, right? So now we will exactly have the same feature for every release from the 3.5. So the feature priority is sort of the plan.
Actually, it's today almost the other way around, that the PySpark has less features than Scala. I think, so I would say that Photon is just an accelerator conceptually, so you don't really care about it, that it runs, it's just like awesomely fast. But it uses the same kind of behavior, so there's not going to be, specific Photon-only features that are available, but it's like the same SQL functionality, except that we take the plan and then we interpret it like in the native code, essentially. But at the end of the day, every PySpark function boils down to like some Scala code. So all of the functions are there in Scala. I've been talking to many different customers, and many customers use Scala because it's like type safe, you can compile it. Once you compile it, it's like, almost working. In Python, it's more like, So, and that's why it's like, depending on your use case, you get like different kind of benefits. So I think what we've seen is, and I think Reynard wrote this as well on the Spark Dev mailing list, is that like the largest fraction of our usage comes from Python. And this doesn't mean that Scala is a bad language, it just means that like, especially for interactive use cases and like machine learning, the world has moved to Python. But I think like on the ETL side, it's definitely, there's lots of Scala there that just will not go away, and this is totally fine. Right, which when I say will not go away, I will ask a question now. Wenchen, will RDDs go away? Will we always have RDDs? Like, is this a feature that is going to stay there? Me as a Spark Connect person, I say like, RDDs, so complicated. I don't want them.
Okay, so I think Spark is built with different layers. So as the first version of Spark, we already have RDD API. Now that's early days. And then we add Spark SQL, so which will compile the SQL query, call the RDD functions. So that's why RDD is still there. It's just one layer below the Spark SQL. And then we can add more features like PySpark and other language boundings, but they all share the same try-to-play interface. But under the hood, they still compile to RDD jobs. So this means that we cannot get rid of RDD unless we replace the entire engine of Spark to use a different API, which I don't say it's not possible, but I think it may happen in the future. And then we can get rid of RDD. So it's kind of, we can still use the same Spark compiler, but at the end, we don't produce RDD, but just produce a different protocol for other new execution engines. That's also doable, just different layers. Yeah, for now, I think people don't use RDD directly, but we still use it as a low-level language for the Spark execution. So yeah, it's kind of already hidden from people, right? People won't see it in doc in other places.
Map partitions.
Yeah, but I don't think it will just go away. But probably, maybe we will deprecate, maybe, but I don't think it will actually go away. Because like once you go in, then it will break everything, like, But our sort of, we encourage people to switch, from RDD to data frame or data set, and then we believe that most of them can be replaced to use the data frame and data set. So maybe in the future, I think maybe we'll just deprecate, but for now, it's just still there. And then just for your information, for the Spark R, we actually deprecate and hit the RDD API. So it's not API anymore. So yeah, in Spark R. But the Python side and then Scala side, I think we are being a bit more cautious. Yeah.
Awesome. Is there maybe anything from the audience where it's say, hey, this is the one thing I hate about Spark, and now I finally have the opportunity to say it in someone's face? Come on, this is a unique opportunity. You don't find so many Spark committers like in one room that you can yell at. I mean, in a friendly way, of course, but you know.
Hey guys, it's a really small thing, but for our logging, we see this like received C command thing in our logging, and it's for one of our streaming jobs, and it just pollutes the entire log. But the more generalized question is, for PySpark, how should we kind of configure our logging and customize it so that's works a bit better and actually logs the things that we wanted to log?
Logging configuration in PySpark. So
Logging, okay.
no worries. Like basically, I mean, I can feel you. Like you log something, and all of a sudden you have like a book printed there. So how can we make this better? So is there something coming?
Logging, actually, we're just okay. For now, we don't have any logging system in PySpark, right? And then we only have like just a couple of like we use the default running package that can be integrated to the Python's built-in logging. And then I think in few packages, we're from 3.4, I think we just started to use the Python's built-in logging system, and then they can be integrated with others. But in 3.5 or 4.0, yes, we plan to leverage this built-in logging so that other people can use it together with their own system or others. Yeah.
Another question would be then be, is there any other cool stuff on the roadmap that you guys could share?
Cool stuff on the roadmap. All right, so when I joined Databricks, I got told like we don't speak of upcoming versions of Spark until they're actually named. So I don't know, like what's coming up? Like what are the things that, I mean, I think that maybe goes into like a question that I prepared as like, what excites you about the upcoming features in Spark?
Only for 4.5. Okay, anyway, so ideally we can talk anything that is not committed by the community. Like we must do a vote on the dev list, say we want to do some feature, and then we can do it. Otherwise, just some rumors, like it's just as rumors. So yeah, so as you see that you see the code that we are building the Python Lakehouse. That is one thing we are building, and then we are. Let me think about first. I'm working on Spark SQL, so let's think about something in SQL side. I think we have built some new features for SQL, like table tables. Right, so it's kind of a pain point for a long time. So in Spark, we only have table views, which is just a virtual place that you must run every time. But for table tables, it's kind of materialized. So you can just save it, and then you read the data without running the query. And we are also want to build a system catalog. So you can qualify your table names. Oh, sorry. You can just refer to your building functions or temporal views that by super name with system at the beginning, so that it's more less ambiguous. What's more in SQL? So anyway, I think we are trying to build the SQL features that are common in other databases. So just to catch up, right? And maybe for Python, I don't know.
Python, you already said most, but the Python, the data source, Python native data source is coming, so you can write your own Python data source only by using Python. And another one is the UDTF, so you can, you can define your own user-defined table function, so you can like define the table-wise operate, and then it generates some rows, and then you can leverage this like together with many cases like ML. And of course, the Spark Connect is one thing. So Spark Connect is, at least for Python side, because I'm working on Python side, Python side is almost ready. It's G8. It's G8, right?
Come on.
Yeah, I missed this keynote, so yeah, it's G8. And then he's actually leading the Spark Connect, the whole project. Yeah, so Spark Connect is one thing. Yeah, there are a lot. There's my talk later. I will talk about that in 30 minutes, so please join that talk.
So maybe then a question on so the PySpark data, Python data source. That's like I'm particularly excited about because that's just awesome. I mean, like dealing with like just random consumption of data from somewhere and like having to write this in Scala. I don't get this. This is too hard for me. Like C++, sure, but like Scala, I don't get this. But maybe something like, are you aware of anything cool stuff coming up for like the ML side? Like, is there? I'm so mean, I know, but. Maybe there's something like in the Flow releases recently where you've seen like, hey, this really works well with like Spark right now.
Yeah,
like,
one of the things actually I think that's a little bit relevant is, and this came out in 3.0, but it's making Spark more GPU aware. So like when you do use Spark or can leverage Spark to use or train some of these LLMs or really with any distributed deep learning workload, there was, I think it was Spark 3, it was released that it basically will map one Spark task to one GPU, which again can be really nice when it comes to scaling out some of like the deep learning and LLM stuff. So that's pretty cool. Like, I mean, if you were in the keynotes today, like there's so much cool large language model ML stuff coming out, but the Spark specific stuff is I think about being able to use Spark as a mechanism to scale a lot of what we see with these massive models, right? Because we see how these are, hundreds of millions, billions of parameters. How do we like reasonably manage these things? And Spark can actually become a really useful tool to do that.
Is anybody of the audience using GPUs actually in Spark?
They're really expensive.
I mean, come on, it's like, wasn't there like here we trained Dolly in like $20 in 5 hours?
Yes, that is true, but I think the GPU we used for that was pretty large.
All right.
Pretty big one, pretty hard to get, but it was done.
Okay.
It was done.
So anybody has been using GPUs with Spark here? All right. I mean, okay, cool. So what other question? Maybe another question from the audience. Anybody, again, wanting to ask something, like experience with Spark, something that maybe, I don't know, what else can you ask? Like something, yeah?
So, sorry. So a question is, with the kind of the use of the LLM kind of enabled the tooling, will I finally be able to understand what my DAGs are doing?
Wow, that's a, all right. Okay. I think yes, awesome. So you've seen Reynolds' keynote talk on PySpark AI. And I think in there, if you look at the PySpark AI package, there's something called explain, which like explains you like what the query is doing. It doesn't tell you what your DAG is doing because, well, not yet. But I think there's an opportunity, and I think this is where like, I mean, summarization of like execution graphs is definitely an opportunity. I don't think that anybody has like specifically looked into that because I mean like this is just so new. Like I mean, Spark as a project is not new, but I think like this whole world, we're just like discovering all of the places where you can use LLMs. And I think definitely making it human understandable is, especially like large plans, I mean, it's definitely a potential opportunity. Any?
I have a question kind of back to you. If you had an LLM like analyze your Spark UI, would you believe it? Or would you say, oh, this thing doesn't understand?
If it helps me debug, then sure.
Yeah.
I mean, I wouldn't just blindly accept it.
Yeah. Some people would. I think you'd be surprised. But that's one thing I'm curious about too. Is like because the Spark community, especially if you're, the Spark community is so in touch with like every in and out of what's happening underneath the covers. And part of like this AI piece of putting on top is like you not lose, but like that some of that control is abstracted away from you. And I'm curious to know like if it would be like adopted well, or if it would be something of like, here's a suggestion, but then you still have the ability to take a look at the data yourself.
I mean, if it tells you it's joins queue, but you're pretty sure it's a disk, like, it's like.
Yeah.
But I think we had 2 newcomers in the room. I think this is the time for you. Like, we're asking like questions like, hey, is there anything that you want to ask like people that work on Spark every day? Something that annoys you, something that you always wanted to know. Is there anything that you would like to ask?
What keeps you guys up at night in terms of Spark?
I'm trying to look at you both at the same time. But it's my context. After like a couple of hours in this room, it's just like really hard. No?
No.
All right. All right, so then I have to go back to my secret book of questions. All right, Hyukjin, what was the one thing, like something that you stumbled across, like somebody using Spark in a way that you haven't thought of, or like that you thought that like was kind of weird or unbelievable?
Yeah, I'll start. Again, I'm from the data science side, so it's a little bit more data sciencey, but we worked with a retailer who was building the scale of tens of millions of models at once using Spark. They're demand forecasting models, so it's how many gallons of milk is this store going to sell on a Sunday, and you can think about that of like by every SKU across a very large grocery retailer for every day of the week, including things like seasonality. It just becomes complex really quickly, and it wasn't necessarily training on a lot of data, right? Because they look at the past like maybe 2-3 weeks of milk sales, but you do this for every single product in every single store. The scale of these models turns to like 20, 40, 50 million models at one time. And just the scale of that and the ease of the way that we were able to scale that with vectorized UDF was pretty cool. So that's my story about Spark being cool.
Vectorized UDFs, Hyukjin, I think you can tell definitely a couple of stories about those. Like, why are they so much better than like regular UDFs?
I think like I talk a lot about this like here and there, so I think people all know. But I mean, it's vectorization.
Right. Who knows vectorized Python UDFs? One person. I mean, I think this is. That's your one opportunity. I mean, look, I've been selling Spark Connect the whole day. Like, I feel like a used car salesman, so it's like I invite you.
I mean, the vectorized UDF is like the previously for the regular Python UDF, we just serialize the row by row, and then we executed each row. So it was like it couldn't really leverage the modern design of the CPU. So for instance, if you take a look inside the CPU, then if you repeat the same operation, then you can pipeline. So you can use the CPU in a more optimized way. So to leverage that, we use the arrow, and then the arrow allows you to SERD like in batch. So let's say let's say if you take a look inside the CPU, then let's say write int, right? And then this kind of operation, we repeat that. Then the modern CPU design can perform this better. So meaning that in arrow, when we serialize, deserialize, then we write the same type in batch. So that leverages CPU, and it becomes much more faster. So that's the one advantage in vectorized UDF. And then when you actually execute, then we use pandas that use the NumPy under the hood, right? And the NumPy design is that they use the CPU maximized way. So NumPy itself support to perform some vectorized operations, meaning that it would again repeat the same thing, right? Let's say array 1 plus an array 2, and then under the hood it will repeat the same thing, like 1 plus 1, like one element in array 1, you perform the operation in batch. So during the execution, you can also see the performance improvement. In short, you do something in batch, and that's faster and efficient, and that batch thing happens, serialization, deserialization, and then execution. So it's much more faster than the regular Python UDF.
And then you can run 40 million models at a time. All right, there's a question there.
So yeah, I actually didn't realize you were talking about pandas UDFs. I use those all the time. One issue I always run into, though, when I'm using or when I'm trying to pass in, say, a NumPy array, is that I always run afoul of some kind of type issue, where arrow can't figure out to turn a float 64, an MP float into the right thing, and I've often resort to using rdd.map to kind of get around this, or converting things to lists. That is, I hate that. That's not a question.
I think this is very much in line with what I was about to ask Hyukjin, because there's this effort of making pandas UDF the default. So how are you going to get around all of the type issues? Sorry to put you on the spot.
That's actually very annoying problem that I'm trying to find a good way to fix up. So thinking hard still.
So let's say like this, I will give you some time to think. So one of the key things is we realized that the usage of like scalar UDFs is just so much higher, and like pandas UDFs, while very powerful, aren't used that much. And it's not because like people fight with like arrow type conversion issues the whole time. You know, it's mostly because it's this other step. So Hyukjin has been leading the effort in like identifying like what do we have to do to actually make it possible so that every Python UDF becomes essentially pandas UDF. But to do that, we have to solve this one problem that I hope that you have a solution by now. No, I'm kidding. But I think this is really, I think like everybody that has ever worked with like pandas UDFs like stumbled across this, like, oh, this is a nan, this is a none. I mean, this is not fun. Oh, wow. That was, I count that as a rhyme, man. All right. Do you have maybe anything to add to this, or it's just a hard problem?
You said everything I wanted to say, so.
It's a hard problem. I mean, we're working on this. I think this is one of those, if it's like exciting upcoming features, you know, the prevalence of Python is there. We want to use this. We want to make sure that it's continued to be used. Oh, wow. Yeah, any other question? I can try again. Looking into my secret notebook here. Sorry for that. Maybe something in history books. Like, when did you encounter the first time Lakehouse? Like, and like first time you heard Lakehouse, did you know what this means? Like, does this analogy make sense to you? I mean, any one of you? Sorry for asking all the field questions here.
You're good. I think intuitively it did. Well, because we got it. First time I heard it was in Databricks marketing materials, but I think we saw those problems a lot in the field of like data lakes are cool and scalable and awesome, but a lot of people lean on data warehouses for like the things that they're really good at, like the metadata management and all of that good stuff. And so I think it was just a really intuitive switch that we still like kind of deal with that transition every day. But yeah, like I said, I think it made sense, and it certainly resonated well with us because we like feel those pains a lot of like, I want to do all these things on my data, but I have to put them in different places because there's different latency requirements. But with Lakehouse, like that in Delta, right, that's eliminated, which is pretty nice.
And now you can read even iceberg tables much faster using Delta. Isn't that awesome? Right. What's maybe your opinion, like for the last 1-2 minutes? Like anybody having like an opinion on like Lakehouse? Like where do you see this? Like, do you want us to do something better there?
So yeah, I mean, I think coming into this week, one of the biggest hurdles for us is, we use Databricks within our ML group, but then the larger organization uses BigQuery. And, you can connect, but it's kind of a pain. And there's no, we can't really use Unity unless we, literally copied all of the company's warehouse into Delta, which we're not going to do. Is the idea now, I guess, with the new Delta, is the idea that we won't really have to think about the underlying, storage, whatever storage, warehouse that is being used outside. We can just automatically read from any source and write to that source, and from the outside world, it works exactly the way it should.
Yes. So I work in a storage group, incidentally. And actually, I work very closely with the folks that worked in Uniform, and I think this is a unique opportunity because, everybody has trying to position their format in a way that basically makes them better. And I think, what you've seen in the keynote as well is, everybody uses Parquet under the hood, and then it's a little bit of JSON metadata, arrow metadata, some whatever metadata that's just there. And I think this is the key part, is there's no rocket science. These are core database problems that people have been solving for the last 40 years. So, and this kind of the ability to translate this into these different, formats is a game changer again. Being able to access Hoodie and Iceberg and whatsoever natively from all of these engines, it's going to be awesome. I think there's still some interesting aspects on this, like concurrent writes and all of this that, we have to figure out over time. But I think just from an access perspective, we deal with customers, they don't want to migrate 5 petabytes of Iceberg data, that's really not cool. So, but being able to like spend, like 20 seconds on like converting the metadata, this is kind of like easy. And I think this gives a much bigger advantage to saying like bringing the different like sources together. All right, I think this was like right on time. So thanks everyone for asking questions, and I want to hear an applause like this loud, like this other group there. So thank you so much for your time.
Thank you.